All right, you guys, today we are learning 7.5, properties of trapezoids and kites. What's really important for you guys to know is that trapezoids and kites are not parallelograms. So everything we've learned so far in this chapter does not apply to these two types of quadrilaterals. Okay? So first thing we need to review is what a trapezoid is. A trapezoid is a quadrilateral with only one set of parallel sides. Okay, so if we look at this picture, you can see we have parallel sides right here on the top and the bottom. Okay, those two parallel sides are called the bases. The two sides that are not parallel are called the legs of the trapezoid. Okay, the base angles are the angles formed with the base. So we have an angle at B and C that are the base angles for the top base, and then we have angles A and D that are the base angles for the bottom base. Now, if the legs of the trapezoid are congruent, then we call that trapezoid an isosceles trapezoid. So just like we had isosceles triangles that had two congruent sides, now we have isosceles trapezoids where the two legs are the exact same length. Okay, so that's when the ones that aren't parallel are the same size. It's considered isosceles. All right, so how do we show that a quadrilateral is a trapezoid? So if you think about the definition, it says only one set of parallel sides. So you can show that a trapezoid is a parallelogram by showing that these two sides are parallel. And how do we show two sides are parallel? We show slopes. We also want to show that these two sides, the legs, do not have the same slope. So that means you have to calculate the slope formula 4 times. So where it says, how do we show a quadrilateral as a trapezoid? We're going to write calculate the 4 sides slopes and show one, I guess I'm going to erase this and write one opposite pair So one opposite pair is congruent and one opposite pair is not congruent. Okay? Then it says, how do we show a trapezoid is isosceles? So once you know it's going to be a trapezoid, then you'd have to show that the legs are congruent. So you would calculate the length of the legs and show they're equal or congruent. All right, that's the distance formula. Okay? All right, so let's take a look at our first example. It says, show that ABCD is a trapezoid and then decide whether it's isosceles. So just like I said, to show it's a trapezoid, we need to show that these pair of sides have the same slope. And then these two pair of sides do not have the same slope. Okay? All right, so just like we've been practicing, we're going to plug in our numbers into the slope formula. So let's start with BC. Remember, y's go on the top. So if you're looking at your y's, we've got 2 and 3 that we're going to plug in here. So we've got 2 minus 3 over, and then since I went from C to B before, I have to also go from C to B again, so 3 minus 0. So we end up with a slope of negative 1/3. And then doing the same thing for AD, we've got negative 3 minus negative 1 over 4 minus negative 2. So negative 3 minus a negative 1 would really become negative 3 plus 1. So we've got negative 2 over 6. And then always reducing, we end up with negative 1/3. So we've shown that these two are going to be parallel. And then we have to show that AB and CD are not parallel. So we're going to calculate the slope of AB and show that it's not the same slope as CD. All right, so AB, again, doing y2 minus y1, so 3 minus negative 1 over 0 minus negative 2 gives me a slope of 4 over 2, which reduces to 2. And then the slope from C to D, we've got negative 3 minus 2 over 4 minus 3. So that works out to be negative 5 over 1, so negative 5 for that slope. So we've shown that they're not parallel. So for it to be a trapezoid, you have to have one pair that's parallel and one that's not, right? We showed that both of these have a slope of negative 1/3, and then we showed that these two do not have the same slope. So it's not going to be a parallelogram, it's a trapezoid. All right, so now we have to decide whether or not it's isosceles. Looking at it, these do not appear to be the same length for the legs, but we still have to show it, right? So we have to find the length of each of these two legs and show that those legs are either equal if it's isosceles, or in this case, I believe them to be different. So we'll find the length from B to A using the distance formula. So our x's go in the first set, y's go in the second set. So that works out to be 2 squared plus 4 squared. So 4 plus 16, which is the square root of 20. And then we're going to find CD's distance, or length. So CD, we've got x's, 3 and 4. The y's are 2 and negative 3. So negative 1 squared plus 5 squared. So the square root of 1 plus 25, which is the square root of 26. So it's not congruent, so not isosceles. So this is just a trapezoid, not an isosceles trapezoid. Okay? All right, so I'm going to have you go ahead and do this U-try. Plot the 4 points to make your quadrilateral, and then you have to show that it's a trapezoid by finding the 4 slopes. And then you have to decide whether it's isosceles by finding the 2 segments that are not parallel and calculating their distance. All right, so have the substitutes, pause the video here, give you guys some time to work through this problem on your own, and then we'll press play and you can check your answers with my solutions. All right, so hopefully we've got this done now. So we should have found the slope of AB and CD. I always like to start with a pair that actually look to be parallel, because I know I'm like, oh yeah, those definitely look to be parallel, so hopefully they have the same slope, which I got the slope to be 1/3 for both of those. Okay, so now we're going to show the slopes of AD and BC. All right, so doing the slopes of AD and BC, AD ends up being a slope of negative 4/3. BC is a slope of negative 5 over 0, which remember that's an undefined slope, which makes sense, right? If you look at this segment BC, it's a vertical line, and that would have a slope that's undefined, right? A horizontal slope has a slope of 0. Okay? So we've shown that it's a trapezoid. We've shown that 2 of them have the same slope, right? These 2 had a slope of 1/3, whereas these 2 do not have the same slope, right? So that's how you show that it's not a parallelogram, that it's actually a trapezoid. All right, now we have to decide whether it's isosceles. So you take the 2 that you found different slopes for, and you show that those 2 lengths are either the same or they're different. That's how you decide if it's isosceles. All right, so AD, we should have ended up getting the square root of 25 or 5. Okay, so this has a length of 5. And then the other side has a length of 5. I know I did the distance formula to get 5, but you could actually count 1, 2, 3, 4, 5 since it's a vertical line. And we would have had our answer a lot quicker than doing the distance formula. Okay, so this works out to be an isosceles trapezoid because the legs are the same length. So we're going to write down that this is an isosceles trapezoid. If you want to abbreviate it, trap, that's fine too. All right, so as you can see, we have some theorems. The isosceles trapezoid base angles theorem says if you have an isosceles trapezoid, then each pair of base angles is congruent. So if you look at the picture, it's just like when we learned isosceles triangles. Remember tick marks? We said if you have an isosceles triangle, if you have the tick mark, starts with a T, then its base angles are congruent, right? That was the base angle theorem. It works the same way here. If these are congruent, then these two angles up top are going to be the exact same measurement, and these two angles at the bottom are going to be the exact same measurement. Okay? Then, of course, we have the converse. If a trapezoid has congruent base angles, then it's an isosceles trapezoid. So if you know these two angles are equal, then you know these are equal. Okay? So once again, if you want to draw this out, you can. The theorem says if you have a trapezoid where these are congruent, the two legs are congruent, then the base angles are congruent, the ones on the bottom and the ones on the top. Okay, but you only have to know one in order to be able to figure out the other. So like if you look at this next example for the converse, if you know you have a trapezoid and you know that the base angles are the same, then you know the sides are the same. Okay, now you'll notice I didn't put the base angles in on the top and bottom, but if you know that one pair are the same, you automatically know that these are the same as well. Okay? All right, and then we have the diagonals theorem. As you can look and see, these diagonals appear to be the exact same length. So it says a trapezoid is isosceles if and only if its diagonals are congruent. So simply knowing that the trapezoid is isosceles, you know that the diagonals will always be the same length. So BD is going to equal AC. Okay? And then a quick little reminder to you all, for any trapezoid, remember consecutive angles are always going to be supplementary. Remember the whole C to C thing? So if you use the two sides that are parallel and you make a C, those two angles are going to add to 180. Likewise, if I choose the other side and make that backwards C, those two angles are going to add to 180 every time. So just another fact that you have to remember. All right, so let's go through some examples. We are told we have an isosceles trapezoid and the angle A is 42 degrees, and we have to find the remaining angles. So remember, if it's isosceles, the base angles are equal. So A and D will both be the same. And then just like we talked about, C to C, if I use my parallel lines to make my letter C, I can figure out what angle B is by subtracting 42 from 180. So B would be 138 degrees. And again, since it's isosceles, the base angles up top are also going to be the same. So C is also 138. So filling this out, we have angle B is 138 degrees. Angle C is also 138 degrees. And D is 42 degrees. Okay, and again, it's because it's isosceles. Now this one, you'll notice it didn't tell us it's isosceles, but we're given some angles. They are base angles, but remember, you can use the fact that because these two are parallel, C to C, right, consecutive angles happen every time you have parallel lines. So if that's 62, it's supplementary with angle D. So subtract 62 from 180, and we end up with 118 degrees for D. And then doing the same thing over here. Subtract 31 from 180, and we end up with 149 degrees for angle C. Okay? So a lot of what we learned in our triangle unit works with trapezoids. Remember a mid-segment theorem that said that this mid-segment is always parallel with the third side, and it's always half the length. So like if this was 40, this would be 20. The trapezoid mid-segment theorem is very similar. The length is a little different, but it's still very similar. So as you can read, it says the mid-segment of a trapezoid is always parallel to each base. So this is parallel to the top and bottom bases. And its length is 1/2 the sum of the lengths of the bases. Okay, so I'm going to write MS for mid-segment equals half the sum of the two bases. So base 1 plus base 2. It does not matter if you call the top one base 1 or base 2 or the bottom one base 1 or base 2. It really doesn't matter. All right, so here it says the mid-segment of a trapezoid connects the midpoints of the legs, right? That's what a mid-segment is. It connects midpoints. So E is a midpoint of AD, and F is the midpoint of BC. So it says if EF is the mid-segment of trapezoid ABCD, then we could say AE equals ED, right? And likewise, we can say BF equals FC. We can also say that EF, the mid-segment, is going to equal half the sum of side AB plus DC. Okay? We also technically know that side AB is parallel to segment EF and segment or side DC. Okay? All right, so it says find the length of MN. All you have to do is add up the bases and divide by 2 or multiply by 1/2, right? The mid-segment is equal to these two added up and this cut in half. So 13.5 added with 18.9 and then divided by 2 or multiply it by 1/2. So 13.5 and 18.9 adds to 32.4, and then 32.4 divided by 2 or times 1/2 gives us that the mid-segment has a length of 16.2 inches. Okay? All right, go ahead and do the U-try here. Figure out what MN equals. So you should be adding up the two bases and dividing it by 2 or cutting it in half, multiplying it by 1/2. So 1/2 of 40. So hopefully we got MN to equal 20 inches. All right, so in this next example, it says find the length of mid-segment YZ in the trapezoid. So since it says the mid-segment, we know we're finding the length of YZ, right? Mid-segment means points or segment that connects midpoints. So there's 2 different ways you could do this. You technically could use the formula that we just did. You could figure out what the 2 side lengths are of the 2 bases using the distance formula and then add that up and divide by 2. The other way you could do it, which I think is quicker, is to figure out what the coordinates are for the mid-segment. So figure out what Y is and what Z is, and then find the distance formula one time. I'd prefer that versus doing distance formula twice, adding it up, divided by 2. I could just figure out what the midpoint is for each of these and then find the distance one time. So midpoint formula, remember, you're just averaging your X's and your Y's of each segment. So like if you look at side PQ, I'm going to average these. So I'm going to look at the X's, which are -3 and -1. I add them because we're averaging, so that's -4, and -4 divided by 2 is -2. And then I do the same thing with my y's. My y's are 3 and -1, which add to 2, and then I divide it by 2. So we end up with the point -2, 2. Okay, remember midpoint formula, where you add them up and divide by 2. You add up your y's and divide by 2. All right, so we're going to do the same thing for the other side. Right, but this time we're going to use R and S to calculate the midpoint. So looking at my x, it's -5 and -1 and 5, which would add to 4, and then 4 divided by 2 is 2. And then I do the same thing with my y's. -3 plus -3 would be -6, and -6 divided by 2 is -3. So we have our coordinates for y and z, right? Y is the point -2, 2. Z is the point 2, -3. Once you have those points, we just need to find the length between those 2 points using the distance formula. Right, y's go in the first set, x's go in the second set. So plugging them in, we should have -2 minus 2. And the second set, we should have 2 minus -3. So we end up with -4 squared plus 5 squared. So it works out to be 16 plus 25, which adding that up, 31 and 41, square root of 41, I believe. Yep. And we are done. So z would be the square root of 41. All right, so we've talked about trapezoids. Now we need to talk about kites. So what is a kite? A kite is a quadrilateral. Again, notice it's not a parallelogram. A quadrilateral that has 2 pairs of consecutive congruent sides. So if you look, these are right next to each other, right? Consecutive means right next to each other. So that's 1 pair of congruent consecutive sides. And then here's the second pair of congruent consecutive sides. Now I need you to note, opposite sides are not congruent. So if you look at the sides that are across from each other, this length cannot equal this. Likewise, this length cannot equal that. Okay, so that's the definition of a kite. Now we have the diagonals theorem. The diagonals theorem says if a quadrilateral is a kite, then its diagonals are perpendicular. So every single time you have a kite, it's going to make a right angle between the 2 diagonals. So that's the diagonals theorem. Okay? And then we have the opposite angles theorem. It says if a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. And it's always the angles between the 2 that are different side lengths. So this angle is not congruent to that, right? But these are always congruent every time. Which, if you think about it, we're just doing congruent triangles. If I add in this one diagonal, do you guys see how we technically have 2 congruent triangles using side, side, side in both triangles because we have the reflexive property? And then all the corresponding parts would be congruent. So angle A would be the same as C. Technically, these angles are the same, right? Technically, these angles are the same. Okay, so you have the whole CP-CTC thing in there, okay? Now keep in mind though, if I add in this other diagonal, is this triangle on the left congruent to this triangle on the right? Definitely not, okay? But they're isosceles triangles, right? Look at this. This little triangle on the left has these 2 sides are congruent. So technically, these 2 base angles are the same. And likewise, you have another isosceles triangle. So these 2 sides are the same. So these 2 angles are the same. Okay? So lots of information that we've used in the past we can use again. All right, so let's look at some examples. So it says find the measurement of B and D. Okay? So hopefully we all know all quadrilaterals add to how many degrees? 360, right? Now, we know that opposite angles we have 1 pair of opposite angles that are congruent. And right now, 85 and 43 are not the same. So that means that B and D must be the same. So all we have to do is subtract the two angles we know from 360. That gives us 232 degrees remaining, and that's what these two equal angles must be. So you would just divide it by 2. So 232 divided by 2 is 116. So each of these two angles would be 116 degrees. Okay? Let's go through another example. So we can figure out what all these measurements are. Okay? So key thing we always need to start with, at least that's what I like to start with, is the fact that diagonals are perpendicular. So I know that I am going to have a right angle for 4. Okay? I also know that I'm going to have a right angle here, here, and here. So all 4 of these are going to be right angles. Okay? So if I pay attention to this little triangle, I've got 180 degrees in every triangle. So I can subtract 90 and 46 from 180 to get angle 3 as 44 degrees. Now remember we talked about, we've got isosceles triangles, right? These two side lengths are the same. So one must be 46 degrees, okay? Also, hopefully you can see that it's reflected. This triangle is reflected over this line. So these are the same, right? Both 46. These are both going to be 44, or you could subtract 46 and 90 again, and you'd get the same answer, 44 degrees for angle 2. Okay? We know that this angle over here is 73 degrees. Right, 73 degrees, so we can use this triangle and subtract 73 and 90 from 180 to get angle 6. So angle 6 would be 17 degrees, okay? And then again, remember, they're the same, right? These triangles are the same. This triangle is the same as this one. So 7 would also be 17 degrees. And then if this is 90, angle 5 is the same as 73. And then we just have to fill it in. So we had angle 1 was 46 degrees. Angle 2 was 44 degrees. Angle 3 was 44 degrees. Angle 4 was 90 degrees. Angle 5 was 73 degrees. Angle 6 is 17 degrees. And angle 7 was 17 degrees. Okay? All right, so this little diagram shows you how all of these relate. So this is everything we've worked on in Chapter 7. So we have all the different quadrilaterals, right? And then we had parallelograms, trapezoids, and kites. So you can see it's broken up into categories, right? So we have parallelograms. Certain ones are rectangles, certain ones are a rhombus, and then we have, of course, the fact that a square is both a rectangle and a rhombus. So if you read this, the thing that's on the bottom is everything above it, okay? Isosceles trapezoid is technically a trapezoid, which is also a quadrilateral. A kite is also a quadrilateral, right? A square is a rhombus, a parallelogram, and a quadrilateral. So you can use that hierarchy to help you figure out information. All right, so it says give the most specific name for each quadrilateral below based on the given information. So the most specific name means like square would be the most specific name, right? Whereas a square technically is a parallelogram, but if you know it's a square, you would say it's a square. All right, so let's take a look at this first one. We have diagonals, and you'll notice that the diagonals are being bisected, right? I can see this length is the same as this length. This length is the same as this length. Now, I don't know anything else. I know that it looks like these 4 sides are all the same, but I do not know that for sure. So all I know is that the diagonals are being bisected. And we learned a theorem at the very beginning that said if the diagonals are bisected, we know it's a parallelogram. So this is a parallelogram. Okay? All right, next one. I've got two pair of sides that are 50 and 51. Notice how opposite sides are not congruent. So if opposite sides are not congruent, I know it's not a parallelogram. I don't know anything about if the lines are parallel, right? If we had anything with parallel, then maybe it could be a trapezoid, but we don't have that. But we do have two pair of consecutive sides, right? They're right next to each other, they're the same length. And I have a second pair where they're right next to each other and the same length. And do we have opposite sides that are equal? No, we do not. So this is a kite. Okay? All right, next one. I know I have a trapezoid. The reason why I know this is a trapezoid because it has exactly one pair of parallel sides, right? I do not have markings showing that these two are parallel, so I know it's a trapezoid. Now the next question is it an isosceles trapezoid? Isosceles trapezoids have diagonals that are the same length. Okay, so if I look at this, is 62 and 75 the same as 80 and 64? Right, if I add this, 64 and 80 would be 144. And then if I add 75 and 62, we get 137. So they are definitely not the same length, so this is not isosceles. This is just a trapezoid. Okay? All right, couple more here. All right, so looking at this one, I have one pair of opposite sides that are equal. Right, these two both are equal to each other. Okay, and then I have that this side is 9. And then I have each of these are equal to each other. Okay, I don't know anything about this diagonal at all. All I know is that I have these opposite sides are congruent. Okay, so if you think about the ones we just did, I don't know if it's a kite. I can't tell if these consecutive sides are the same length. Okay, I can't tell if it's a trapezoid because I don't know if they're parallel or not. So then I go back to my parallelogram rules. Do we have any parallelogram rules? I don't know if both opposite sides are the equal because I don't know what this is. So there's really not enough information to really figure out anything. So this is simply a quadrilateral. Okay? And then our last one here. I have one pair of parallel sides that are the same. I do not know if I have two pair of parallel sides, right? So I know that this is a trapezoid. And then because the two sides that aren't parallel are marked off as congruent, that makes this an isosceles trapezoid. Okay? All right, you guys, so that is it for our notes. So the substitute will pass out a worksheet, and then that worksheet needs to be done for class on Monday. So make sure it's all done. All right, have a great weekend.